Uh, Good morning, all of you. Myself, Dr. Kailash Kalare. Today, I am going to present one of my contribution during my PhD work. The title of my PhD thesis is Deep Learning Framework for Limited Data Image Reconstruction. In this presentation, I would like to discuss about the image reconstruction, the state-of-the-art image reconstruction approaches, and the limitations that we have addressed uh, from these state-of-the-art approaches. So here I'm going to discuss one of my contribution, that is the artifact removal using deep neural network, RegDNN. So this RegDNN architecture has been designed to address the issue of image reconstruction from limited view projection data. So in this presentation, I would like to introduce you about the image reconstruction problem. So here we might come across different types of machines like CT machines, MRI machines, the PETs. So basically, these machines basically has two main components. One is called as the X-ray source, and another one is the X-ray detector or sensor. So basically, image reconstruction is being used in various applications such as industrial applications as well as the health applications. So an object of which we have to do the CT that has been placed in between the X-ray source and the X-ray detector. Then from different angles, this X-ray source and detector is being moved around the object, and the projection data is being generated. So uh, after generation of the projection data, this projection data has been passed to the different reconstruction algorithms, and then this reconstruction algorithm reconstruct an image. So there are different traditional approaches which are exist in the literature. One of the approach is called as the transform based approach, and these are the direct inversion methods. The examples of these transform based methods are filter back projection or the convolution back projection. The basic advantages of these transform based methods are the accuracy and efficiency, and they are also helpful in removing the artifacts. But the main drawback of this transform based method is these transform based methods requires full view projection data. So if we consider an angle of 1 unit, so these transform based methods provide the good reconstructed image only when we have to take the 360-degree projection data. And this transform based methods also requires the accurate interpolation, and these methods are being used popularly in commercial CT. There is another type of methods for image reconstruction which are called as the iterative methods, and these are also been referred as the successive approximation methods. The basic examples of these iterative methods are the algebraic reconstruction techniques, SART, as well as the MART. The iterative methods are simple as compared to the transform based methods. They also require less projection views as compared to the transform based methods. However, these methods are being found as compute intensive. Uh, Nowadays, machine learning, maximum likelihood, expectation maximization, least square methods, and deep learning methods are also being proposed. And these methods are categorized into another type of image reconstruction method that is called as the optimization based methods. These are also the effective in terms of the number of projections required. However, these methods are also compute intensive as compared to the iterative methods. And these optimization methods are giving the approximate solutions, rather the transform based methods are being giving the accurate results. And the basic advantage of these optimization based methods are they require the less projection data, less projection view data. So the basic applications of this optimization methods are the medical imaging. So we have seen that there are three major types of image reconstruction method, that is transform based method, the iterative methods, and the optimization based methods. As we have seen that the image reconstruction is an inverse problem wherein we have the projection data and we have to reconstruct the object of that particular projection data. So this problem is the ill poor ill condition. So we don't get the exact solution using the ART or the optimization based methods. So our first contribution was to address the issue of the image reconstruction from the limited view projection data. So we have seen that instead of taking full view projection data, is it possible for us to reconstruct the image from the limited view projection data? So we have addressed this issue using the Regdian and architecture. So as we can see in this example, we have tried to reconstruct the image from the 60 projection views as well as the 30 projection views respectively. And we can see that in this case, these transform based methods as well as the uh, algebraic reconstruction techniques produces the unwanted artifacts in the image. And with these artifacts can be categorized as the ring artifacts as well as the strict artifacts. So we have tried to address this issue. So first of all, I would like to discuss the building block of this image reconstruction, that is called as the projection data or the radar transform. So Redan has proposed the formulation of the projection data. So this equation number one specifies the Redon transformation, that is called as the projection data. So here this Ps of theta is nothing but the projection data which is being acquired from the object ux, and the main objective of the image reconstruction is to reconstruct the object mu of x from this Ps theta. Uh, as we have tried to remove the artifacts from the traditional methods that generates these artifacts on based on the limited view projection data. So we have formalized the problem of image reconstruction using deep learning as an optimization problem. So what we have did here is we have reconstructed the image with a limited view projection data, and these reconstructed images shows the artifacts in that, and we have considered the ground truth of these reconstructed images, and we have did the training of this Regdian architecture based on these images with the artifacts and the ground truth images. So here this Regdian and theta is nothing but the learning weights which has been generated after training this Regdian architecture in supervised manner. So we have trained the network that is called as the Regdian architecture. Our Regdian architecture is composed of the three main building units. So this unit architecture has been proposed by the Roneberger in 2015 for the segmentation. And we have used this Regdian architecture and we have modified this Regdian architecture. We have modified this unit architecture and formed the Regdian architecture for the artifact removal in case of the limited view projection data. So in this case, this Regdian architecture has three main components. One is called as the pre-reconstruction unit, another one is the reconstruction unit, and third one is the post-reconstruction unit. So this pre-reconstruction and the post-reconstructions are having the similar structure, whereas this main reconstruction unit is bigger than this pre-reconstruction as well as the post-reconstruction unit. So the basic idea of adding this three unit is to reconstruct the image properly using the limited view projection data. And we have taken the images, the CT images which has been available in the TCIA, the Cancer Imaging Archive repository. We have considered 70 to 100 images, out of which we have uh, 3600 images that do not have the noise, and the 3600 images has the 10% of the Gaussian noise. From these 70 to 100 images, we have uh, generated the data set, uh, and we have used the 80% of the data set for training and 10% for the testing and 10% of the validation respectively. Here we can see the objects which are the city images, real city images. So we can see that object 1, object 2, these are the different types of objects that we have considered for our training. After performing the training of the Rigdon and architecture, we have validated our proposed approach on the newly data set, newly images. So we have tried to reconstruct the images from different projection views. In this case, in this diagram, we can see that the projection data has been considered as 35 projection views, and from these 35 projection views only we can able to reconstruct the image, and we have compared our approach with the state of the art filtered back projection approach, which is obviously the transform based method, which is said to be accurate. But in this case, this transform based method is generating different types of artifacts, and we can see that our proposed approach is able to reduce these artifacts from this particular reconstructed object. Similarly, we have tried for the 40 view projection data, and we can easily see that our proposed approach is performing better as compared to the filter back projection method in case of the 40 projection views also. We have compared our performance based on the different performance metrics like mean squared error, NR, MSC, SSIM, PSNR. So these are the basic comparative metrics we have used for the comparison of the proposed approach with the filtered back projection approach. So we can see here that we can able to get the improvement of 2 to 3 dB PSNR as compared to the filtered back projection. Even in case of the limited view projection of 35 and 45 projection views respectively, we are able to reconstruct the object which is having the SSIM around 87.4.87%. We have compared our proposed approach with the state-of-the-art approaches like KSVD, BM3D, CNN10, CASTNet. So it has been found that our proposed approach is able to reduce the RMSE as well as the improvement of the PSNR with respect to the state-of-the-art approaches. We can see here that our proposed approach is uh, similar to the BM3D approach. Obviously, this KSVD algorithm is good as compared to our proposed approach, and is giving the PSNR greater than the proposed approach. The then we have tried to remove the beam hardening artifacts. So the basic difference between the normal stick and ring artifacts and the beam hardening artifacts is all the traditional methods consider the X-ray beam as a chromatic in nature. However, the X-ray beam is the polychromatic in nature. So basically, when this X-ray beam is being passed to an object with the higher intensity, it generally generates the beam hardening artifacts. So in the figure, we can see that the ground truth is in figure 7a, and however this figure 7b shows the beam hardening artifacts over these high intensity objects. So our job is to reduce or to remove these beam hardening artifacts from the reconstruction image. So we have considered the Regnien architecture for removing the beam hardening artifacts too, and we have used some objects which are available at this particular website, and we have tried to reconstructed these images from these particular objects. So these objects are being considered by taking into consideration that these objects has the high intensity objects. We can see that these objects are showing the high intensity areas. So the traditional methods generates the beam hardening artifacts over these high intensity objects. So we have reconstructed the image from this PBU phantoms uh, with the help of 35 projection views as well as the 40 projection views. Uh, we have also tested or validated our approach on the real-time data which has been given from the IIT Kanpur. So this particular object is being pass through this X-ray machine, which is mini machine, which is available at the IIT Kanpur, and this is the configuration that is there while reconstructing this image. So that was the image has been given from the proposed method uh, after removing the beam hardening artifacts. So in this case also we have used different types of state of the art approaches, and we have reconstructed the images using the less view projection data. So we can see here that this uh, MABEL approach is taking the 180 projections over the 180 degree. However, we are able to get the reconstructed image similar to this ABEL in 119 degrees. Similarly, we have also used this low dose dental CBCT data for the validation of our proposed approach. So here in case also within 133 projection views, we are able to reconstruct the image which is similar to the Baera et al. Method. Uh, so these are the journals. So this was my one of the contribution during my PhD work. I would like to thank you all for listening me patiently. Thank you all.